Today we are going to discuss a wonderful topic which is nothing but boundary condition between two dielectric medium. Before moving to the topic, we must understand what is meant by dielectric medium and what is meant by boundary condition. Boundary is nothing but interface between the two different medium. So, boundary conditions which helps to understand the electric field and electric potential, behavior and its characteristics. So, here in this image I shown the electric field which is passing from medium 1 to medium 2. If we know the characteristics and behavior of the electric field in the medium 1, we automatically find the medium electric field and its characteristics in the medium 2. So, next we move to the dielectric. Dielectric is nothing but a material. It is not used to conduct electricity, but it helps to store the electric charge when we applied the electric field. So, dielectric is also called as an insulator when it can also polarize when the electric field is applied. So, example for the dielectric is glass, plastic, mica and ceramic and so on. So, here there are different types of boundary conditions. So, boundary between first one is dielectric and dielectric, second one is conductor and dielectric, third one is conductor and free space. So, today we only learn about dielectric and dielectric boundary. In this image, the thin sheet is act as a boundary between the two different medium. So, medium 1 is dielectric, medium 2 is also a dielectric. So, here we consider a Gaussian pillbox extending equally above and below. In this image, the Gaussian pillbox, the height of the Gaussian pillbox is del h, the length of the Gaussian pillbox is del omega. So already we know the electric field which has both normal and tangential component. The normal component of the electric field is perpendicular. The tangential components is parallel to the field. So for normal component, the normal component of the electric field is always discontinuous. Here E2n is the normal component of the electric field in medium 2. E1 is nothing but normal component of the electric field in medium 1. Second one is tangential component. Tangential component of the electric field is always continuous. So, E2t which try to indicates the tangential component of the electric field in medium 2. E1t which try to indicates the tangential component of the electric field in medium 1. In electrostatic field, the voltage around the any closed surface must be 0. So, which represents V is equal to minus integral of E dot dl equal to 0. From this diagram, we try to understand the concepts. Okay, length of the pillbox is represented by del omega. Height of the pillbox is del h. Then, half of the pillbox, I mean height of the pillbox of the medium 1, right? So, which is represented by del h by 2, which is equally nothing but similarly height of the pillbox medium 2 is del h by 2. Okay, from this diagram only we try to write the equations. So, in the first term, the E1t, we multiply the electric term and as well as the length of the pillbox. So, first term I indicates E1t multiple of del omega. The second term which indicates the direction. So, only I indicates the negative sign here. Then, second term which indicates E1n, the multiple of del h by 2. Then, third term is minus, so the negative direction again. So, this is a perpendicular direction, that's why only the negative direction, negative sign is indicates. So, E2n is the multiple of del h by 2. Then, this is also the perpendicular and opposite direction. So, again I take negative sign as a common. So, fourth term is E2t into del omega minus E2n del h by 2 minus last term is E1n multiple of del h by 2 equal to 0. So, the next term, the second term and then sixth term will be cancelled. Then third term and fourth term will be cancelled. Then the equation becomes E1t del omega minus E2t del omega is equal to 0. Then we take del omega as common. So the equation becomes del omega into E1t minus E2t equal to 0. So E1t minus E2t is equal to 0. Then I take E2t into right hand side. So the equation becomes E1t is equal to E2t. So this equation E1t is equal to E2t, which try to represents the tangential component of the electric field are continuous and same on both sides in the dielectric medium 1 and dielectric medium 2. If there is no charge enclosed on the box, the rho s is equal to 0. Rho s nothing but surface charge density. So dN1 is equal to dN2. D is nothing but displacement vector. If there is charge enclosed on the box, the rho s is not equal to 0. dN1 minus dN2 is equal to rho s. The electric flux density is always continuous across the boundary if rho s is not equal to 0. Then normal component of the displacement vector, which represent dN1 is equal to d1 cos theta 1. Second one is dN2 is equal to d2 cos theta 2. The tangential component of the electric field Et1 is equal to E1 sin theta 1. Et2 is equal to E2 sin theta 2 by applying these four values in this equation. By applying the boundary condition at rho is equal to 0. Rho is equal to 0 means surface charge density is equal to 0 on the surface. Right? So dN1 is equal to dN2. Here I apply the value of dN1 and dN2. So the equation becomes d1 cos theta 1 is equal to d2 cos theta 2. Here I take this equation as 1. Then second one is Et2 is equal to Et1. So I substitute this equation Et1 and Et2. So the equation becomes E1 sin theta 1 is equal to E2 sin theta 2. I taken this equation as 2. Here we divided the equation 2 divided by 1. So then the equation becomes E1 sin theta 1 divided by D1 cos theta 1 equal to E2 sin theta 2 divided by D2 cos theta 2. Already we know sin theta divided by cos theta, which represent the tan theta. So the equation becomes, and also I substitute the displacement vector value. Displacement vector is equal to E1 into epsilon naught. So I substitute this equation. The equation becomes E1 divided by E1 epsilon 1 into tan theta 1 equal to E2 divided by E2 epsilon 2 into tan theta 2. By in left hand side I cancel the E1 and the E1, then in right side I cancel the E2. Then the equation becomes tan theta 1 divided by tan theta 2 is equal to epsilon 1 divided by epsilon 2. It is the boundary condition between two dielectric medium. Thank you.